Hello everyone and welcome to this lecture. In this lecture we are going to talk about application of multiplication of matrices. Alright, we need to remember some key points here. Number one, as we said in our earlier lecture, that in multiplication of two matrices, resultant matrix always inherits rows from the first and columns from the second, right? The second key point, which is new, and it's related to the application topic, and that point is resultant matrix not only inherits the number of rows of the first and number of columns of the second, but it also inherits the significance of the rows of the first matrix and significance of columns of the second matrix. Alright, so let me repeat these two key points regarding the application of multiplication of matrices. Point number one, in multiplication of two matrices, resultant matrix always inherits rows from the first and columns from the second. And second key point is resultant matrix always inherits significance of the rows of the first matrix and significance of the columns of the second matrix. Alright, so let's explain these two things, specifically point number two, by using one example. Alright, okay, you need to write that question down. Question is, a coffee shop sells both latte and iced coffee, right? A short size of either cost $2 and a tall cost $5. During a specific time of a day, the number of latte and iced coffee sold are given as 5, 10, 12, 13. So we can say in a specific time of a day, we observe that a coffee shop sold 5 small latte, 10 tall latte, 12 small iced teas, and 3 tall iced teas, right? So the matrices pertaining to the above information is given by. Now if you see and if you compare, you can easily decode this matrix by using table as your key. This first row signifies the latte, and the second one tells you about the iced coffee, and the first column of A tells you about the small, and second column of this A tells you about the tall. Alright, and if you try to decode this matrix B, you can say the first row shows the small, and the second row shows the tall, and the column shows the cost. Alright, now in the first part we need to find A times B. Alright, so in the first step, check the validity. So if you see order matrix A, it's in the order of 2 by 2, matrix B, it's in the order of 2 by 1. Since number of rows, so the number of columns of the first matrix is equals to the number of columns of the second matrix, therefore we can say A into B is true. Alright, A into B is valid. In step 2, we need to execute the multiplication. Rule is all the available rows of the first matrix interact with all available columns of the second matrix. Alright, so first row interacts with the first column, and rule of interaction is first multiplied with first, second multiplied with second, and we need to add them together. Alright, since we are interacting second row with the first column, therefore address should be 2 by 1. So 12 multiplied with 3 and 3 multiplied with 5, right? So 15, 50, 36 and 15. If resultant should be 65 and 51, right? Now the question is, what is the significance? If I ask you in the second part, after multiplying, explain the significance of your answer in part 1. So we have already decoded these two matrices. If you see this first matrix, rows are latte and iced coffee, columns are small and tall. In the second matrix, rows are small and tall, column is of cost. In our previous lecture, we have already discussed that the resultant matrix always inherit number of rows of the first and number of columns of the second. So if you see the resultant matrix and its order, the order is 2 by 1, means number of rows of the first and number of columns of the second. The second key is the significance, which we need to discuss here. If you see the significance of the rows of the first matrix rows signifies latte and iced coffee, right? And column of the second matrix signifies the cost. So this resultant matrix, since resultant matrix inherits the significance also from the first rows of the first and from the columns of the second, therefore we can say the row significance is of latte and iced coffee and the column significance is of cost. So 65 shows what? The total cost of latte, and 51 shows the total cost of iced coffee.